before this output, we are designing the loom. Okay, using the loom, we are designing the things. Okay, so let's go to the logic scene. So here, so last time we looked at that. We are initializing some instruction inside of this loom. So we are giving some 3 instruction: add die, and add instruction. Then when the PC value is the first one, then the output is coming out. This is the first instruction. And then we know that 0 is coming out as a raise the 0 value. And we have to take the immediate value from this one. So the selection bit should be 1 in the case, and then 3 is coming out, and output is now is a 3, right? The 3 is waiting for that. So if we are toggling, then this is 0, and the instruction is add instruction, and this one is not 1, this is 0, so this is instruction is. It's too much clocked. Okay, so let me reset it. Clearly. And clear that this is first instruction. Clock. Then this is a second instruction, which is assigning 6 into the register. So anyway, this is what we are trying to do. So let's make this input part using the loom. Okay. Okay, so let us make a loom control part. Okay, so let's add control. Okay, so I add the control. Change the control. So here we will receive in the input, which the first one is OP code. It's a 6-bit. Okay. Then to support the alt time, let's try to receive function part also. Is also 6-bit. So this function part is only available when OP code is 0. Okay. So our type case, this is meaningful. Anyway, we are receiving this 2 part. And what we have to do is that if this is 0, then we have to generate some value based on this function part, right? Okay. So anyway, if this is changing, then we have generated something. So what we are doing is we are adding memory loom. So we are adding a loom here. And the loom case, the input is, so it's a 6-bit. Okay, so 6-bit is input. Okay, then we are generating some output value. What output value do we have to generate? So we are adding splitter here. Okay, So what kind of output do we need? The first one, register destination. Second one, ALU source. Third one, register or memory. So we are defining the MUX selection input. And then whether this is a branching or not, branch. And then we have to update the register value or not. And what about the memory read or rewrite? Then maybe we can give some another one, like whether we have to jump or not. It's a jump instruction, we have to jump. Then we are giving some function operation for ALU. Okay, so the name should be different. Function. This is for it. Okay, so these output should be determined. So how many bits do we have to decide? 1, 2, 3, 4, 5, 6, 7, 8, 12 bit. Let's say this is 12 bit. Okay. So 12 bit output is coming out and receiving the input, and this is also receiving the 12 bit, and then generating 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 cases. 10 of these, 9. And then this is there is 1, 2, 3, 4, 5, 6, 7. 5, 6, 7. The last one is 8. Okay. So first one is connected to the first one. Second one. Second. Third. Connecting each value. Okay, so last bit is depending on. So everything is 0, then this ALU function is depending on this function type, right? So everything is 0 case, we have to do something, okay? Otherwise, if it is not 0, then this 4-bit is just coming out to the ALU function. So just leave as unconnected. So anyway, what we have to do is, so OP code is 0. 0, then what that instruction? OP is 0. That is all type instruction. Okay. So then in that case, what's the output? Raise the destination, which is a register destination. Here, the destination is this one. Okay. So this is the register destination. This input. So to select RT or RD as a destination register. Okay. So here, let's go to the control. Okay. Everything is 0, then what is register destination? Is it from the RD or RT? So 0 means the R-type case is simple. R-type case, as you can see, yeah, it's just RD, right? So RD should be destination. So as you can see that, so the first one, so this is should be 1, right? So 1 means, okay, so this is RD part, and 0 is RT part. Okay. So opposite. Let me see. It's RD, RT. Okay, so if this is 1, then RT. If this is 1, then RT as a selected as a destination. If it is 0, then destination is selected as a destination. Okay, so the control to select RD, it should be 0, right? And then AL resource. AL resource is here. This one. So what value do you have to choose for the alt-type instruction? 0 or 1? If it's 1, that means immediate value is chosen. If this is 0, then register value is chosen. So R-type case should be, this should be 0. Okay. So this is also 0. And then register to mem means the figure, there's mux here. Okay. This mux case. So whether we are choosing the output of register or it should be chosen from the memory. Okay. So this is only chosen when we are executing the load instruction. Okay. Load instruction is only updating the register value. So if it's not load, then it is 0 should be provided. So control signal is where this value is also 0. Okay. Branch. Definitely this is not the branch. So this is also 0. And register write. Are we updating the rest for the alt type? Yeah, that's true. Okay. So this is 1. And what else? memory. So this is not memory operation. So the memory should be also 0. Okay. Value is not access to memory. I'm right. So this should be 0. And jump. This is not jump instruction. So let's. So this 4 value 0, 0, 0, 0, that is 0, right? And 1, 0, 0, 0, that is 8. Okay. So what we are adding is that the first one should be 0, 8, and last 4 bit is depending on the function. So let's say this is like 0. Okay. So last function part, let's say this is 0. So we will writing 0, 8, 0 for the first item. Okay, so we are going there. So it has some problem. Always it has a problem. Redraw it. Instead of this, I'm using the lower one. Actually, this is the last bit. The B position should be opposite. Okay, so is opposite. So this is a higher bit. So 0, 0, 0, 1, 0, 0, 0, 0. So that means the last highest 4 bit is actually representing function. So 0, 1, 0. That's the correct one. So let's change the content to 0, 1, 0. So but still 0, 1, 0. So okay, so this is not updated. It has some bug. Let me change it. 6 bit, 12 bit, and 0. That. So you can see that the OP code is 0, 0, 0, then left right is only 1, and the others are 0. Okay, you can see that. Then let's look at another instruction, which is add I. Add I case OP code is what? 0, 0, 1, 0, 0, 0. That's the OP code. Okay. So if this one is 00100, that is chosen, that address is given. So this value should be properly put. So at the I case, raised destination is from the R key. And this is value source is from the immediate. Raised to mem is not memory, and it's not branch. And raised to update, yes. And it's not memory read, memory write, and it's not jump instruction. Okay. And the function part is the function is it should be add instruction. So let's say add is 1. Okay. So 0001. That's the function part. Our type case is 000. Okay. So the first 4 bit is 8, and next 4 bit is 1, and this one is 3. So 8, 1, 3. That should be written in this law. So 8, 1, 3. This 8. It's a long problem. Long has some bug. So if this is not gonna work, then you have to redraw it. So here. And then so I updated it. So this is not gonna work. It has some bug, so I'm changing it. Okay, so if 00100 is given, then so this is 1, this is 1, and the right is 1, and the others are actually 0, and function part is 1. Okay, so if this is not 0, then we are just outputting this function part. Okay, what else? What instruction we have to do? Load instruction. Load instruction case, and it's 1000 1. it is 2, 3, 2, 3. You are giving 1, 0, 0, 0, 1, 1, 2, 3. So here this should be mobile instruction case. Destination is actually destination is the RT is used. The destination and the air source is 1. Register to man is memory should be used 1. It's not branch. Register should be updated. Memory read. It's not memory write. Not jump instruction. And this is add instruction. Okay. So what this one? 4, 8, 3, 7. 8, 3, 7. That should be written here. Okay. Eight, 3, 7. Every time test problem. And then 123. This one is 6. So actually, after you're setting all the value first and then connect the port. Otherwise, it's not going to be working. Anyway, similarly, you have to do every instruction. Store instruction, which is 1, 0, 1, 0, 1, 1. Then branch instruction 0, 0, 0, 1, 0, 0. So similarly, you have to give. So this is, it doesn't matter, right? So store instruction case or register destination is not going to be used. So it's not doesn't matter. So X, but X means that you can give any number, 0 or 1. Anything is okay. So we will assign in 0 there. And this is 1. Doesn't matter. This is 0. It's not updating the register. Not reading, writing, not solve. It's adding. Okay. So location is 2B location, 2B. So 2B location, what we have to give? 8, 4, and A4, and this 4 bit is 00102. Okay, so this is that one. And what's the branch case? Rest destination. RD, actually there is no RD, right? Branch instruction case. RD is not going to be used. So it doesn't matter. Area source from the register. So we have to compare two register value. Okay, so ALU is actually comparing the two register value. This is 0. Updating the register, we are not updating. And in this branch, yes. And register update, no. The memory read, no. Write, no. It's not jump instruction, branch instruction. And function is comparing. Let's say comparing. Anything, it's okay. Like it's subtraction, it's doing the subtraction 0, 0, 1, 0, for instance. It doesn't matter. Okay. So this value should be written into the long. So 0, 0, 0, 1, 0, 0, which is 4. In the 4, what value do you have to write? It's 4, 0, 8. 4, 0, 8. Okay, so there, 0. Okay. This one, let's connect. So branch instruction case, this branch is just coming out. Okay, so can you make this component? Someone is asking me that why the first one is changing. Because the only reason is that here the mux. So this is 0, right? 0 is now, it was RD value. I think this is RD, and this is RT. So if we are connecting the other ways, then this is same to the last time. So it's depending on the connection. So if we are connecting this one to here, then opposite. If we are connecting like this, then 0 means you are taking the RT as RD. Okay, so it's opposite. That's the only reason. So it's only depending on your decision. So if you are drawing like this, then you have to make a control value like this. Okay. Okay, so if you actually similarly, if OP code is everything is 0, then the function part, the function part is depending on this function, right? So what we are doing is we are choosing some what else? Where is it? multiplexer. So multiplexer, using this multiplexer. And this is 4-bit input. And 4-bit output. And we also add some ROM here. This one is also 6-bit input. And output is only 4-bit. Okay. So 4-bit. Then this will be and then what we are doing is, if all value is 0, then we are taking the first one. If all thing is not 0, all thing is 0, then we are taking the second one. Because everything is 0 means R-type case, we have to look at the function value. Okay. Otherwise, we are looking at the first one. So we are at header, which is six-bit input. And we're adding splitter here, which is 6-bit input and 6-bit output. And this is connected. Everything is 0. Everything is 0 means nothing is 4. So everything is 0, then the output is 0. If one of them is 1, then output is 1, right? So everything is 0. Then we have to take in. So let's change the port. So this is connected to 1, and this is connected to 0. So everything is 0. Then we are taking the 0. So 0 is actually from the function norm. If one of them is 1, like this, then the lower one is chosen. Okay. So if OP code is not 0, that means it is not the R type. Okay. And function part is depending on the things. So for instance, add instruction, function code is 10000. Okay, like function is 1000000. Then it is add instruction. So in the case, the function should be 0001. That's the function. So here, if this is 10020 part, zero. Error. bit input, 4-bit output. 1000 is 0 is 20 is 0. First and forward is so it is all type instruction case, then the function is 100, then the output is 001. That is add instruction. Okay, so can you make this design? And is if you are completing this control, then what is left? You have to add this control in the MIPS. Okay, so here you are adding control in some place. Okay, so here, so it is receiving OP code and function. So OP code, this is the OP code. So we are connecting this OP code here. And function is last part. So connecting the function. Okay. So then you can see that the OP code is is 001000. So add I. Okay. So then you can see that the destination is 1, and this is 1 0 0 0 1 0 0 0, and this is your function, right? So we have to just connect them. Okay. So the first one is connected to here, destination. So now, can you try to connect everything? So remove this one. And then second one, the value source is here. Let's do to memory. So here. And branch instruction. So whether this branch, actually it has a 0 part. So branch is true and 0 is true, then this is selected. Okay. So what we are doing is this. Let's change this instruction fetch part a little bit. Instead of that, just add here. And logic here. Input smaller one. Let's say both are true. So branch is true. And also this is 0. 0 is true. Then let's take it to jump. Also true. Okay. Third one, fourth one, that's the right. Is this one, load signal. And here, memory read. Load signal here. Memory store. And then jump instruction that should be provided to the instruction fetch. I think here this is jump instruction. Last one, so ALU function. So ALU function, this is ALU. So this is ALU function. So now we are completing. So someone is asking me the branch equal. Actually, the branch equal case, we are not using the output of this ALU, we are using some another one, 0, right? So there is a special output. So we will use this one. So it doesn't matter which operation is using. Always this 0 is comparing the two values. If this is true, then this is 1. Otherwise, it is 0. Okay. So for the branch equal instruction case, we don't care about that. Okay. Okay, so can you continue to connecting all the control part? I'm going to change the content of this long part to make the add is 0001. And someone is asking me that instruction fetch. And the instruction fetch. You mean, are you asking about this part? Kim Dong-hyun, what is you're asking? Yeah, this is not constant value. This is just input. Okay, so here you can see that the port is here. Address. Address is coming out from the instruction. So in the instruction there are how many bits? 26 bit is coming out from here. So this 26 bit is connected to the address. Okay. So instruction fetch, even this is a 0, but it's not actually 0. Okay. So it's default value. So anyway, the input 26 bit is coming into here. And the last 2 bit is 0 and 26 bit is copied, and another 4 bit from the current PC value. Okay. So if you are looking at the instruction, it's a second instruction already. It's 6. This is 1. Okay. So if I'm running again, then next instruction. Okay. So the instruction is the add instruction. Add instruction case. So you have to check whether everything is okay. All S, all T, all D. And this is correctly coming out. And list 1 is not updated correctly. Let me reset. Reset. So the first instruction, 3, destination is 1, and toggling. Then this is 6. Rest 2, and toggling. Then add the instruction 9. Okay, 3 plus 6 is coming up. So if you are completing this one, then you can see that that 3 instructions are executed correctly. First register is 3, and second register is 6, and correctly chosen to the 6. Value output is 9. 9. And this is 0, so this is 9. It's waiting, and destination is 3. So register 3 will be updated. ALU. So this is ALU. So 2-bit input, and you have to add some logics, add or subtractor and or XOR anything, and give the mux. And function is actually the selection bit for this mux. So now what is left is if you're changing the ROM, right? ROM and you're adding more, if you want to support more instruction, you're just changing the control part to support more instructions. And so here, and if you're changing the instruction fetch, there is a ROM. So if you can program here, so you are changing the program, then you can run some different programs, okay? So you can test branch instruction or jump instruction. And currently we are not supporting the jump and link or jump register, but anyway, for the other instructions, almost. For the branch, we only support the branch equal. We are not supporting branch not equal, right? So maybe you can change a little bit to support those instructions. Okay, so anyway, implementing all things, this one is kind of your homework, okay? So this one should be supporting the 3 instructions, which is add I, and add. Okay, so that should be working. Okay, so completing this one is kind of homework, and next time we will continue about how to improve the performance of this MIPS design. Okay, so if you are making this logic sim, then you can understand how the data is processed, right? Okay. Any question? No, okay. So then you have to keep going to implement this control part and connecting all of that. Okay. See you. Bye.